Hello, this is UTT Pump Jack, but more formally known as Team 16. Today we will be going over motivation and background, design and methods, final design, and conclusion. First, we have our motivation and background. What we have is an oil pump jack, which is a mechanical lifting device commonly used in the oil industry. It operates by converting rotational motion into linear motion to lift oil to the surface. We decided to do an oil pump jack because oil is still a crucial energy source in today's world. Hence, being able to extract oil efficiently is vital for optimizing our resources to ensure that we have a stable supply, and it helps maintain lower energy prices. We were able to design an oil pump jack through a CAD software to model and simulate the pump's performance, allowing us to make adjustments based on simulated operational conditions. Now in this slide, you can see oil is still being widely used around the world as energy, accounting for nearly 80% of global energy, hence why developing a 3D printed prototype to create optimized and lightweight pump components is crucial in order to enhance operational efficiency.
Designs and methods. For our design, we wanted to design something with optimized geometry, meaning we wanted to make components that would improve fluid dynamics as well as reduce energy during operation. We also wanted a modular design, which means that every component would be easy to replace and able to adapt to various conditions. We watched various videos and studied multiple pictures in order to figure out how the parts work individually as well as together as a whole. As you can see, the drawing of our final design is on the left alongside our bill of materials on the right. So now I'll be going over some important parts. So first we have the pitman arms. These are two rod-like arms that are used to convert the rotational motion of the crank into linear up and down motion of characteristics of the pump. Without these pitman arms, the oil pump jack would be inoperative. Next, we have the counterweight and crank. Counterweights typically weigh around 20,000 pounds and are utilized to balance the system, minimizing the overall energy required to operate an oil pump jack. They help the system run efficiently and smoothly while the crank is attached to a torque shaft. So next, we have the walking beam and horse head. The beam is connected to the horse head at its front end and is attached to the pitman arms at the rear, which are linked to a power source. The horse head provides a smooth arc-shaped motion, helping to prevent stress or friction that could damage the sucker rod or well components. Next and lastly, we have the Samson post. The Samson post is a vertical robust pillar located beneath the center of the walking beam. It acts as an anchor or main support for the fulcrum, which is basically the pivot point of the walking beam. This support allows the walking beam to pivot up and down without shifting or losing stability.
Final design. Through our trials and design tests, our final prototype has come to look like this. In the future, we have the potential to add an additional feature that mimics the drawing of oil from the ground along with a smaller driving gear for efficiency. Here are two pictures of our final design.
So here is our oil pump jack actually in motion.
Conclusion. This 3D printed oil jack design shows off the actual mechanism used in real-life oil jacks, which are used for oil production. It puts an emphasis on accurate design and realistic motion, showcasing the different parts and how they interact with each other. We learned many things throughout this project, including how to turn large complex machines into functional models, 3D printing techniques, project planning, and more. We also faced challenges like holding meetings, making the project functional, and 3D printing tolerances.
If you have any questions, feel free to ask about our project.